Alright, so lesson 7.1 today. Two things you'll really need for today's lesson is graph paper and some sort of straight edge, whether it's a ruler or it can be anything that you can at least draw a straight line with. We'll be graphing. So chapter 7 is all about systems of equations, and with 7.1 we're going to be using the graphing method. Okay, so lesson 7.1, graphing method. And the reason I say a ruler is just in order for us to get the correct answer, we need to be really exact with our lines. And so we want to make sure that they're absolutely straight lines and going right through the points. Okay. So what happens is you'll be given, so let's go through an example. You'll be given two equations. So let's say x plus 2y equals 7 and 3x plus, or excuse me, it's minus 2y equals 5. Okay. And they'll ask you to graph both of these equations. Now, both of these equations you can see are not in y equals form. They're not really easy to graph using intercepts, so I'm just going to try and change them into slope-intercept form. So need it y by itself, so subtract x to the other side. All right, 2y equals negative x plus 7. Okay, then divide by 2. I want to do that to each term so that we get 1y equals, now remember this is a negative 1x, so this is negative 1/2 x, and we'll just leave it as plus, 7 divided by 2 would be 3.5. Okay. Now if we look at the second equation here, I have negative 2y, if I subtract this 3x on both sides, equals negative 3x plus 5. And then divide everything by a negative 2. And I get y is equal to a negative divided by a negative is a positive, so it's going to be 3/2 x. I leave it as an improper fraction because it's easiest then to graph with my rise over run. And then I have, it'd be minus or plus a negative 2.5. Okay. So from here, what we're going to do is we're going to graph these on a coordinate plane. We're never quite sure where they're going to intersect, so drawing a nice large coordinate plane is helpful. It doesn't have to be huge. It'll usually be around 0 just with these type of problems, or the way the book sets it up, but we do want at least a little bit of room. And then we're going to graph both lines on this coordinate plane. So let's look at our first one. The y-intercept is at 3.5, so I'm going to come up 1, 2, 3.5. Okay. And then my slope is negative 1 over 2, or negative 1/2. It could be 1 over negative 2, either way. So I think of it as rise negative 1, run 2. And that's what I'm saying. We want to make sure and be as precise as possible when we do this. And we also want to try and do as many points as we can as we go through this so that we can get an accurate line. So right, I can go down 1 to the right 2, or I can go up 1 to the left 2. Up 1 to the left 2. Alright, so take my straight edge. I'm going to draw a line through those points. Okay, so there's my first line. Then I'm going to go to my second equation, which y-axis was at negative 2.5, so down 1, 2, 5. And its slope was rise 3, so 1, 2, 3, run 2. Rise 1, 2, 3, run 2. And so we see there that these lines should intersect when I draw this line through it. And you see that they intersect here at this point, which it looks like is the coordinate point 1, 2, 3 over 3 up 2. Okay. Now, hopefully you can see there, right? If I wasn't really precise about what I was doing, that point of intersection could be off a little bit, and it would make it difficult. I mean, personally, so we're going to learn multiple different methods here for solving systems. And I think you can see here in this first one why probably the graphing method is not the best method, because you have to be really careful that you're precise, or the lines get a little bit off and you might look at a different point, and then if it doesn't intersect right, at 2 whole numbers, then you're just estimating, which isn't very good. But the reason we do graphing method first is so that you can visually see what's happening. Right? We want to be able to show that this solution is the point that is on both lines. It's where they intersect. Now, we can always check our work, right? So if we want to make sure that this was the correct point, not that you'd have to do this on every homework assignment, right? In the homework, you can always check just using the answers. But on a test or a quiz, it would really be good to check and make sure you did it correctly. So, right, any coordinate point is always x comma y. So we had our 2 equations, x plus 2y equals 7. Well, if I plug in 3 for x, 2 for y, and c, does it work? Well, 3 plus 4, does that equal 7? Right, yes it does. And then I'd check the other equation. 3x minus 2y equals 5. 3 times 3 minus 2 times 2, does that equal 5? Well, 9 minus 4, that does equal 5. Alright, so we had the correct solution. Alright, I'm going to go through one more example, and that'll be our notes for today. And then you'll be able to work on the work. So, let's say we have negative x plus y equals negative 7. And we have x plus 4y equals negative 8. So if I draw my coordinate plane here, so one thing too, you can see here, I think because of COVID and things, and this, I think you may have missed out on how to graph using intercepts, but I'll show you real quick. It's always an option. Now you can always change it into y equals mx plus b, and that's perfectly fine. Use your slope and your y-intercept. But a trick you can do is we can always graph using the x and y-intercepts. So if we look here at the first one, so I can always find my y-intercept by plugging in 0 for x. So if I plug in 0 for x, what happens? It disappears. So what's my y-intercept? Well, negative 7. So come down 1, 2, 3, 4, 5, 6, 7. And if I want to know my x-intercept, well, I plug in 0 for y. So what happens to the y? It disappears, right? And I got negative x equals negative 7, right? Negative x equals negative 7. So divide by negative 1, and my x-intercept is at positive 7. 1, 2, 3, 4, 5, 6, 7. There's 2 points. I know it's, I can draw a line through it. There is one of my lines. Then if I want to look at my second equation, it's also set up pretty perfectly to do this. If I want to know my y-intercept, I put in 0 for x. That means that x is going to disappear. So you have 4y equals -8 divided by 4. My y-intercept is -2. And if I plug in 0 for y, what do I get? I get x equals -8. So my x-intercept is -8. 1, 2, 3, 4, 5, 6, 7, 8. It'd be over here. That's enough. Alright, so if I take my straight edge and line it up through that, we should see that they intersect at the point 1, 2, 3, 4. So x is 4 down 1, 2, 3. Right here, x is 4 over 4 down 3, -3. So that would be our point of intersection. Again, we could always check that, plug in x for 4, -3 for y. Well, -4 plus -3, that equals -7. 4 plus -12, does that equal -8? Yes, it does. Okay. It's posted on Canvas, but right, your classwork is on page 430 in your book. And you're doing numbers 4 through 28 every fourth. It's not a lot of problems today, but I just want you to take your time on these graphing ones because it's really important that you're accurate and precise, which is something that some of you struggle with. And we'll talk about that on Monday because some of you on the test were not very good about being precise again. All right. Hope you have a good weekend, and I will see you Monday. Bye.